Hello, everyone, and welcome to the MS Robotics Program Open House. We're excited to share with you information about the new program that we have. Before we get started, I do want to go over a few housekeeping rules for the meeting. First, the meeting is being recorded and will be shared at a later date. And also, for that reason, if you could please keep yourself muted during the presentation. We will be having a Q&A at the end, where you can ask questions. If you do have questions throughout, however, though, you could always use the chat. We are going to be having team members on who can help answer questions through the chat. And then if you want to speak your question or add it into the chat after the presentation, again, we will have that Q&A. So without further ado, I'll go ahead and I'll pass it on to our robotics program chair, Amit Roy Chowdhury, to go through and start our presentation. Welcome.
Hello, everyone. Thank you for making the time. Thanks, Angela, for introducing and for giving the housekeeping rules. So on the panel today, besides me, we have Angela Maluski, Kim Underhill, who will be the contact person for the robotics program for any questions, any administrative questions that you have. Jun Sheng, who's a professor of mechanical engineering, and Jun Wang, who handles international admissions. I may have the I may not have the exact terminology. Excuse me for that. And we should all be able to answer any questions that you have. I would actually like to start by sharing a different screen, Angela, if you do not mind. And I would like to show you this website. I don't know how many of you have had the chance to look at it, but this is a picture of UCR. And this shows, so this is a drone that's flying. This is something on, this is with robotics. This is one of our professors in robotics. And with robots, this is on virtual reality and augmented reality experiments that some students are doing. This is on face tracking. And this is students' work and the faculty working in the robotics lab. So I just wanted to do that. Angela, you can start back on that. So I just wanted to show this to you just to give an idea of some of the things that are going on currently. So although this is a new program, the area of robotics and artificial intelligence is not new at all. This is something that many of us have been working on for quite some time. And the program was built in order to pull together resources across three departments: mechanical engineering, electrical and computer engineering, and computer science and engineering, where there's a lot of work in robotics and artificial intelligence that is going on. And now we are providing a single platform for all of you to be able to work in this area. You can choose from different areas. We go through this. You will. I'll give you more details about the program, and you will see that you'll have a lot of flexibility depending upon your interests. So without further ado, let's go through the details. So we'll start off with some information about UCR, about the Bourns College of Engineering, and then we will provide introduction to the robotics program. Some highlights about the program, the admission requirements, and finally questions and answers. With that, I'll hand over to Jun Wang.
Thank you so much, Amit, and thank you everyone for joining us tonight to listen to our presentation on the robotics programs. And before we share more details about robotics programs, I would like to introduce our university to you. So we are the University of California, Riverside, one of the proud member of the University of California systems. As you may know, we have 10 prestigious universities in the system, making us the largest public research university system in the world. And our campus has a long history of academic and excellence in research areas. We started the campus in 1954 with our heritage in agriculture and citrus research. But it has quickly grown to a comprehensive campus with 7 colleges and 150 degree disciplinary areas. We're very, very strong in our industrial partnership, including areas like robotics and many other areas in engineering. And we're very well known for our excellence in engineering and employment opportunities, both in the United States and internationally. Currently, the UC Riverside campus has roughly around 26,000 students, including 3,700 graduate students. And out of the 26,000 students, 2,500 of them are international students. So very proud of our diversity, and the students come from over 70 countries around the world. So UCR is a rising star. We have grown so much over the past 2 decades. And in fact, the last 2 years, we were praised by the US News World Report rankings, as well as many other rankings as the fastest growing and on the rise university in the nation. And if you look at the spots we have improved over the past 2 years, for example, the Forbes magazine, we have increased over 80 spots. And by US News World Report, we increased to 33 spots in ranking. And that really shows the fast speed of our size, as well as our excellence in research and academic areas. So you cannot introduce any university without skipping the rankings, right? So we are, as I mentioned earlier, not just fast growing, but we are also excellent in many categories. For example, 2 years in a row, we are ranked #1 in social mobility in the nation, which means we really provide the students with the highest number and amount on return on investment. And we provide the job opportunity to students, as well as different research or career opportunities to students, both at graduate and undergraduate levels. We're also top 1% university worldwide, and rated top 35 for our best value in the nation as well. And many magazines and agencies have ranked us very highly for our best value aspect. The return on investment is reflected in almost every single disciplinary, especially in engineering, because of the hot demand in terms of job opportunities from the industry. So where is Riverside? So Riverside is actually, I would consider, the best place in the United States for study, for living, and for social events. This is really a dream place to be, considering the diversity, both for weather as well as for enrichment activities. So we are living in Southern California, 1 hour east to city of Los Angeles, and we're close by all the attractions. So this is 1 hour to Disneyland, 1 hour to the snow resorts, 1 hour to the beach, and 1 hour to the deserts and wineries, and many things to do here. It is also a historical city. It's the birthplace of Naval Orange. So if you may be familiar with like Sunkist or the other orange brands, this is where it's from. So we have that history, but we also have that vibe, economy, and also has the local industry support. So it is a very unique city with this 1 hour radius, gets you everywhere. And it's also in a very drivable distance to San Francisco, San Diego, or many other places that you may already know. And so it's internationally connected, but also very much enriched with a lot of things to do. And Riverside, UC Riverside on its own is also a very vibrant community. We are top ranked in many elements, including our food choices on campus. So we have 26 restaurants on campus providing all different kind of food from all over the world. We have Chinese, Italians, Mexican, Indian food. Everything's available here. So if you have different food preference, you can always find it over here. We have halal food, for example. We also have vegetarian options. And we have a lot of state-of-art recreational facilities on campus. For example, the picture you're looking at is a very state-of-art recreational center that was built a few years ago. And it was a hosted place for Paralympics, as well as many other important games. And we have an indoor track, we have a heated pool, and many Olympic level facilities right here in our backyard. And the campus is full of excitement, entertainment, so we never get bored when you come to join our campus. So a little bit more about our College of Engineering. So our College of Engineering is named after the Bourns family, and it's called the Marlan and Rosemary Bourns College of Engineering. It is one of the largest semiconductor and electronic components company right here, headquartered in the city of Riverside. And the Bourns College of Engineering right now have roughly around 900 graduate students, but we have 134 award-winning faculty members, which makes the graduate to student ratio 7:1. So you still get that personal attention, a lot of the small classroom settings, and very, very enriched research environment with plenty of funding opportunities. So out of the 134 faculty members, 76 of them are fellows of their professional societies, again, showing the excellence of our faculty profile. And the college ranking is equally excellent, and we are the top 50 public engineering college by US News World Report in 2021. And we are top 20 global engineering school in the United States by US News 2021. As you can see, we're much, much higher ranked and recognized by the global community, by the foreign universities and international market. So we are also top 31 in terms of our starting salary by pay scale 2020. So you can see that we have a lot of job opportunities and really well-paid job opportunities for our graduates. And next, I will pass it on to Dr. Jun Shan, who will share more about our robotics programs.
Hi everyone, thank you for coming to the information session. In this slide, I will give you introduction to the robotics program and talk about some highlights. So we believe the robotics at the UCR BCOE is a good opportunity for you. As you can see, the UCR is already top ranked on several robotics related areas, such as high performance computing, design automation, embedded and real-time systems. And this new program is supported by 3 departments and 1 program, including the electrical engineering, mechanical engineering, computer science and engineering, as well as computer engineering. And the faculty members in these programs and are supported by a lot of prestige government and private fundings from the prestige government and private entities, such as the Department of Defense, National Science Foundation, and so on. We believe by taking the robotics master program at BCOE, you will be able to get into this quickly, this exciting area, which has a 40% increase in hiring over the last 4 years. So then I would like to talk about some highlights of program. Basically, there are 3 compositions of this program, which means you have to complete these 3 parts to graduate. Okay, so first you are required to take like 5 core courses. As you can see here, it includes 2 ME courses, 2 WE courses, and another cross listed between CS and WE. And by taking these 5 courses, you will learn a lot of fundamental things in robotics, such as the computational methods, design and fabrication, linear control systems, sensing, navigation, as well as artificial intelligence. So this is required for all students, all robotics master students. And the second part is more flexible. So students will be required to take 3 courses in one of the 4 focus areas. Okay, and the last part will be like you have to take 2 elective courses, or you have to finish a project. So on the next slide, I will talk about what's the composition of these focus areas. So the first focus area is artificial intelligence and perception. So you can see there are more than like 10 or 15, about 10 to 15 courses for you to choose. And they're both undergraduate and graduate levels. So this gives you an opportunity to learn a lot of different areas in the artificial intelligence, such as data mining, imaging processing, computer vision, as well as general artificial intelligence and artificial artificial intelligence for design. Okay. The second area is the control and the navigation. So in this focus area, you can learn fundamental control theories such as feedback control, nonlinear control, and digital control, as well as several specialized control courses. For example, you can take Introduction to Robotics, and you can also learn intelligent transportation systems. And the third one is embedded platform and system design. There are also a list of very interesting courses, and they're provided by both EE and CS, such as the GPU design and also real-time embedded systems. The last one, but not least, is mechanical design and fabrication. So all these courses will be provided by mechanical engineering, and you will learn a lot of different aspects in the design and fabrication. So for example, you will learn how to do the sustainable product design, and you can also learn how to use artificial intelligence to design the product and design the robot. Okay. Then I would like to explain what is the third composition of the program, which is the elective courses or the project. So there are two options. The first one is that you can do a project, okay? And there students taking this option need to do a project under the guidance of faculty member. And you can take 8 units of the CSWE or ME 297. So ME 297 is 4 units, right? So basically you need to do research for 2 quarters. So actually a lot of master students are already doing research in other programs. But the special part of this program is that this project needs to be approved by a committee of at least 2 faculty members. And it requires a presentation and a written report in the end of the 2nd quarter. So this can make sure you have a high quality in your project. So the second option is the comprehensive exam option. So this includes 2 parts. First, the students need to take 2 elective courses, and that's totally like 18 units. And then you need to take a comprehensive exam about the core and the focus, the courses you take in the core and the focus areas. And about the elective courses, you have a lot of options. For example, you can take any courses in the focus areas, and as long as it's not used to satisfy the focus area requirements. And you can also choose many other courses available in the 3 departments. And if you want to know more details, feel free to go to this website to check other courses. And then I would like to emphasize that a lot of, actually all the faculty members in this program are affiliated with our Center for Robotics and Intelligent Systems. So this is a new center. And as you can see, there are 4 research areas, and these 4 research areas of the CRIS Center are well aligned with the 4 focus areas. And researchers in this center are doing cutting-edge research in different on the foundations and application of intelligent and autonomous systems. For example, some potential applications are like the security, biomedical systems, environmental monitoring, and so on. And in particular, the researchers in this center are also collaborating with industrial partners, and we are trying to solve real-life problems and to get some cross-disciplinary solutions. Then we would like to introduce some details in the 4 research areas. The first one will be the control of the robotic systems, and you can see like there are many faculty members in these areas, including myself. And people in these areas are working on the control problems of robotic systems, and such as the surgical robotics, prosthetic hands, and the soft-legged robots, as well as the flying robots and the rehabilitation robots, and so on. So next on the next page, I would like to hand over to Professor Amit Chaudhary, and he will talk about other research in the machine intelligence and other aspects.
Okay, thank you, Jun. So let's continue from where Professor Jun Sheng left off. So as he said earlier, there are different focus areas, and specifically there are 4 focus areas. One is on the mechanical design, is on the control and navigation. The third is machine intelligence and artificial intelligence. And the fourth will be on embedded systems. And if you join this program, you can choose to specialize in one of them. As you know, artificial intelligence is kind of this very hot area of work now. And we have a very strong group of faculty working in this area. To give you an idea, so Professor Asif, Professor Oymak, myself, Christian Shelton, Vagelis Papalexakis, we all work in machine learning, and some of us also work in computer vision specifically. Professor Chen works on augmented reality, virtual reality. Professor Karides works on robot navigation, planning strategies, and so on. So between us, this is a very strong group of faculty working on different aspects of artificial intelligence. And this is something that you can work on if you join the program. Next. The other aspect of robotics is mobile communications. So robots often have to communicate with each other, or they have to communicate with the base station. This is extremely important for them to be able to navigate so that they don't collide into each other and so on. And it's very important to be able to deal with these communication aspects, whether it's with the cloud or whether it's with other robots. And we have a very strong group of faculty working on different aspects of communications, from the physical layer communication like Ingbo Hua, Ertem Tansel, Jiasi Chen, to those who work at the higher, and even Srikant Krishnamurti to some extent, as well as those who work higher up in the communication system, for example, network protocols, transport layer communication, and so on, like Professor Ramakrishnan, Professor Abu Ghazali, and Professor Krishnamurti. So communications is a fundamental part of robotics. Drones cannot fly unless they can communicate, or a legged robot cannot move around unless it can communicate either with the base station or with others. So this is a very, very important aspect of robotics, and we have a very strong team in that aspect. The other aspect of robotics is embedded systems. All of these that we have been talking about, whether it's the control, communication, the artificial intelligence, all of it have to run on a particular hardware platform, and it has to run within a certain number of cycles. This is actually what makes robotics often much more interesting than just running something in the cloud where you have maybe almost infinite resources and you can take a lot of time. You cannot do that with a robot. If it sees an obstacle, it needs to navigate around it. Think of an autonomous car. You've all read about the accidents, for example, that have happened. And if you had infinite time, probably that system would have been able to recognize that there was an obstacle in front. It would not have bumped into a person. But when the car is moving down the road at 50 miles per hour, you don't have infinite time. You have at most a couple of seconds. And you have to make the decisions within that very small amount of time, within the clock cycles of the computer that is available in that amount of time. And that brings in the aspects of embedded systems. All of these fancy algorithms, whether control and navigation, whether it's for artificial intelligence, whether it's for communication, have to run on that chip. And this is where the embedded systems comes in. And faculty like Professor Abu Ghazali, Professor Philip Brisk, Professor Hissun, and Professor Najjar, they work on different aspects of real-time systems, FPGAs, embedded GPU units, and so on. So we've given you an overview of the different research areas, and the courses are built along these research areas. So there are these focus areas, and these focus areas are designed so that you can choose one of these research areas. But there are aspects, for example, communications, which is not a focus area, but you also have the freedom to take some electives, and you could choose some of those courses in terms of the electives also. At the end of the day, where does a robotics degree lead you? It's probably the best program that one can think of in terms of the job opportunities that open up. There are, of course, the big companies like Microsoft and Google, where there is a lot of openings for robotics, whether it's in autonomous navigation, in augmented reality or virtual reality, whether it's for designing better vision systems, better AI systems. But beyond that, there could be companies in mobile communication, for example, at Cisco, which works on mobile communication. SpaceX and Boeing, which works a lot on aerial robotics. Intuitive Surgical or Boston Dynamics, which works on like humanoid robots. There could be work in defense companies like Northrop Grumman or Boeing and so on. Uber, for example, Uber and Lyft are investing a lot in autonomous driving. NVIDIA, they work, they do a lot of work on embedded systems and chips that would go into a robot. So there could be Toyota, again, autonomous driving. Intel, that builds the chips on which the robotics algorithms have to run. Tesla, of course, again, autonomous driving. So all of these companies that work on different aspects of artificial intelligence, whether it's building the mechanical design of the robot or whether it's building the AI that actually allows the robot to understand the world around it, all of these companies, all of these opportunities open up with a master's degree in robotics and AI. I would also like to say the following over here, that an undergraduate degree provides some of the basic training, but there is very little that is taught at the undergraduate level that would allow or that provides a skill set to be able to work in many of these companies. For example, an undergrad almost knows nothing about the technology behind autonomous driving or the technology behind, let's say, what Boston Dynamics, like a humanoid robot that is able to take different actions. These require a set of courses that are far more advanced than what is typically taught at an undergraduate level, and having a master's degree opens up all these opportunities. This is also a good thing about the undergraduate degree and the PhD degree. So the undergraduate degree doesn't give the kind of background that is needed to work in a very fast developing area like this. The PhD degree is basically for students who have done research, who are able to do things on, they've learned to do a project on their own, not just a project, a thesis on their own, a multi-year thesis on their own. And they appeal to these companies also, but at a certain segment, which is basically on the research. But there is the bulk of the work in companies is on the development side and what is called research and development. And for that, the master's degree is actually a great opportunity because the courses you do in your master's program are the same courses that PhD students take. And PhD students might take a couple of more advanced courses, but for the vast majority, it's the same set of courses. So you are getting the same technical skills that are needed in order to go and work at these companies, but which is not available at the undergraduate level to be able to make an entry into this high-tech domain. Okay. So that's okay.
And these are some of our alumni testimonials. And we work to guide our students to set our students up for academic and professional success. And we have employment options on the next one. And so student employment are through internships on campus during their degree. Summer is very common for people to get an internship. And then also after degree completion. And we have a whole international office because a lot of you may be international students, a whole international office that will support you and guide you to help you figure out the best options and to help you with your visa and immigration as well. And I'll go over the admission requirements. So the international applicant deadline is July 15th, and we encourage you minute, the sooner to us, especially if you need a visa, the sooner we can help get you processed. Domestic applicants, the same thing. We have until September 1st to submit, but please just go ahead and submit. Even if you start your application early, at least we can start working through the process and help guiding you and setting you up for success. You do need a bachelor's degree in these related fields or an equivalent. Unofficial documents are great. We love unofficial documents. Let's letters of recommendation. And the GRE is optional this year. So that's great news if you don't already have it. If you do have the GRE, go ahead, submit it. And then if you are having trouble with either English language, a TOEFL or an IELTS is generally required, but if you have trouble with that, go ahead and reach out and we'll work with you on that as well. If your testing in your country is going on, we'll work with you and guide you. And then there's 2 personal statements, a statement of purpose and a statement of personal history. You can find more information on our website or reach out by email and we'll help guide you through the process. And these are the contacts, the email that I mentioned. If you have any questions, feel free. I know a lot of you have already reached out and some of our team are listed here who will help you and be working on the admission side once you submit your application, initially guiding you through that process.
That concludes the main session of our presentation, and we're open to Q&As to see if any of you have any questions. Feel free to type it out in the chat, and we can answer them for you. Right now we have some time left, and please take advantage of this opportunity, especially our program director, admission officer, and graduate advisor are all here at the same time.
Hi, so I have a question. I just graduated from mechanical engineering at UCR, and I actually got accepted into the BS plus MS program. So my question is, how is that, is that separate from the robotics program? And my second question is, if I have a mechanical engineering background and I want to choose my concentration in artificial intelligence, would that be like a 2-year or like more than 2 years for me, or how is that shift gonna be for me?
So Kim, can you answer the first question and I'll take the second one?
So I think the first question was the difference between mechanical and the BSMS versus robotics. So those are different programs with different degrees on your diploma. And the BSMS is very specific. So if you're here at UCR and you meet certain criteria, then you just continue on and do the master's as part of that program. So that's just for a very specific set. That wouldn't transfer between different majors, right? The mechanical major for the bachelor's goes straight to the mechanical master.
Okay, thank you.
Okay. So in terms of the second question, can we go back to the slide where we have the program, the courses, etc.? Okay, no, one slide before this. Yes. So to answer your question, so if you have a degree in undergraduate degree in mechanical, can you transfer over to robotics? Absolutely, yes. In fact, that is exactly how we ended up designing this program. And it should not take you 2 years. In fact, it should probably just take you the same time as everybody else. So if you look at the courses, there are 5 core courses. And these core courses are designed such that students from different backgrounds would still be able to go in and then choose the focus areas. So as somebody with a mechanical engineering background, the first 2 would be something that very much falls along the lines of what you have done. The third one, control systems, I assume as in mechanical engineering, you've done control, so this would also be a standard progression. Then the sensing and navigation and the machine learning. So these would be probably new courses for you, but these are the basic beginning level courses. So if you look at the backgrounds needed for these, they are not very different across the different programs. So basic mathematics backgrounds, basic programming background should be enough to take these courses. And once you have taken these courses, you can then have, so if you wanted to move into artificial intelligence, so CS229 or EE240, which is the beginning level course in machine learning, that will allow you to then go in and take the focus courses. Can we move on to the next slide now? Yeah, so now when you go into the focus course, say, so you've taken that. Now, if you wanted to take some other courses from here, let's say an advanced computer vision or advanced artificial intelligence, you would be able to do that because it'll give you the prerequisites. The other thing you could do is there are elective courses. There are a certain number of undergraduate courses that you can take. And if you wanted to, you could take, for example, 142. This is actually E140. This is actually cross distance now between E142 and CS171. And you could take that course, which will provide you with the background needed to take 229. And you can take 2 undergraduate courses in the program. So this will allow you to build the background and then move into the focus, move into the more advanced courses. So it should not, you would not need to do more than 40 units, irrespective of the undergraduate background that you come in. Essentially, you might find that you need a couple of, or maybe one undergraduate course in AI, while a student from CS might need one undergraduate course in, let's say, control, to be able to take the required courses and complete it but within 40 units. Okay.
Okay, thank you.
Hello.
Yes.
So yeah, I actually find myself in a very similar position to Mahmoud, who asked the last question. Just to make it absolutely clear, we would be required to submit another application in order to attend the robotics program. If you're already from like the mechanical engineering, for example, right?
Kim?
Any instruct, but yes, you would want to submit a new application. But once you submit, if you email robotics with your new app ID number, then we will work with the mechanical engineering department to get all of your documents transferred over, so you don't have to resubmit everything.
Oh, so I can work with the application I've already submitted. Okay, sounds good.
And since you said you already submitted it, you would need to do a new one. Tell us so we can help you transfer it over. If you have saved applications, you can just hit copy and duplicate them. But once you submit, it's locked in. So then you just email us and we will help you out. But you just let us know what you want to transfer over from any other program that you've applied to, and we'll work with them to try and get that all applied. So you don't have to keep resubmitting all the documents.
Absolutely, that makes a lot of sense. Thank you.
Yeah. Thanks for the good question.
Okay. Yeah. Thanks, Kim. I see a couple of questions. I wanted to go through them. And again, so somebody wrote about that they wanted to, interested in control and navigation and embedded systems, a graduate of mechanical engineering. Again, so the robotics program is designed to be able to move across disciplines. So because you graduate in mechanical doesn't mean you wouldn't be able to move into, say, control and navigation. So as in mechanical engineering, I would assume you've done at least one control course. And so it should be not a non-issue to move into control and navigation. You would take one of the core courses whose prerequisite is undergraduate course, and then you can move in to the more advanced courses. To move into the embedded systems area, again, remember, we allow 2 undergraduate courses that you can take. So you can take the undergraduate course as part of your degree requirements, not as something extra. Build the prerequisites and then go on to take the more advanced graduate courses, which would make you more appealing to the companies if you're applying in terms of having specialized in the embedded systems area. And there was Another question is, which skills do you want a graduate student to have before starting MSc in control and navigation, like programming language and other things? So again, so in order to specialize in control and navigation, so the specialized, you do not need any specialized skill if you have done a degree in mechanical, electrical, computer engineering, or computer science. The entire goal is to be able to take the basic skill set and build on top of that. So if you wanted to go into control and navigation, again, you've taken an undergrad course, you've taken linear algebra, you should be able to build on top of that. And plus you have the option to take some undergrad courses in this program, and then you can take the more advanced courses. Okay. So if there is anything specific regarding this that is not getting through, or you want me to clarify, just let me know. I'd be happy to do that. But I hope this gets across that the program is designed to provide flexibility, because robotics is a very, very interdisciplinary area. To be able to work with robotics. So think of an autonomous car, which is kind of an exciting concept nowadays, right? Need to be able to do control, you need to be able to do sensing, to be able to reason about the environment, and do all of this on an embedded platform within a fixed number of CPU cycles. And the program is designed to give that kind of flexibility.
So, Professor, I know you mentioned that we don't need to do any extra thing. But if, like, let's say for me personally, I'm not great at coding and I want to get more familiar into it. So in summer, I'm trying to like get an online course or something just to understand more about coding. So what do you recommend, like, as a language to start in? Like, what is the language that we're going to be like that would be needed all the time in this program? Okay,
very good question. So it depends on this focus area. So if you are planning to specialize in embedded platforms, you need C++. If you're planning to focus on control and navigation, it will be MATLAB and Python. If it is artificial intelligence, it will be Python. So if you are, so I think you are the one who asked the question about AI. So if you are interested in AI, I would suggest Python. And MATLAB is something you probably know.
Yeah.
Yeah. So I would suggest doing a course in Python.
Thank you.
Okay, very good questions. And I'm happy you asked all these questions about being able to move from one undergraduate specialization. And that's exactly what we want to do.
So Amit, actually received a few questions in advance as well, mainly similar to the questions the students has brought up, basically come from different areas. Can they be able to handle the curriculum? Because the curriculum is very diversified and cross-disciplinary. Many students, the background is in EE, but they do not have the mechanical or CS courses at all. So very minimum CS courses, like introductory to C++. They're wondering if they can take some prerequisite classes in addition to the 40 units.
So can we go back to the previous slide? Okay, so if it is a EE background, I think there should be absolutely no problems. So the computational methods for robotics, this is basically on linear algebra methods. This is something EE students do day and night, and there should be absolutely no problems. Linear control systems, this is what EE students do. Sensing and navigation, this is basically, again, sensors and basically building on control systems. This should also not be a problem for EE students. And machine learning, pattern recognition, depending on where you did your undergraduate degree, you may or may not have done this in an EE program. But again, the basic principles of that are in linear algebra. So I do not expect a EE student to have any issues with this. The only course that could be different is on the design and fabrication of robots. And over here, Again, this course is designed, and June can probably say a little bit more, but these courses, these core courses are designed such that you do not require a specific degree in the department that this acronym stands for. So these will be courses that will be built on basic undergraduate training that all of us receive in mathematics, in programming, and building on that, you should be able to do that. And on top of that, again, let me clarify, maybe we should have put this into the slides here, is you have the flexibility to take a couple of undergraduate courses. So if you really need that, you could take an undergraduate course in order to do this. Do not expect that you need to have anything specialized in any of the programs to be able to take these core courses. Rather, these core courses provide you with the flexibility to decide which focus area you want to go into. And in fact, we have currently students in the EE Master's program who come from different backgrounds, and they are able to do these courses because these are not the very advanced courses. They are the beginning level courses. So June, can you say something about the ME 225?
Yeah, sure. So the motivation of creating ME 225 is to let people who have never built robots to learn how to build robots. So don't worry about it. So you will learn how to build a robot in this course. And for example, I know a lot of researchers are working on commercial robotic systems, right? So and then sometimes maybe during your experiments, some hardware is broken, but usually you would ask the vendors, ask some technician to come to help to fix it. But maybe the paper deadline is like 1 week later and you don't have time to wait. So if you have the knowledge and the skills in this kind of design and fabrication robots, you may have a chance to repair it if the problem is not significant, and then you can just recover the robot and continue doing what you should do. So in this course, you will learn the basic design and fabrication skills in creating these kind of robots. I believe most students will be able to handle it.
Yeah. So again, let me. So this is really important to understand that these courses are built so that irrespective of the undergraduate program you come from, you will be able to do this. And why do we do this? Because if you actually go in to work in a robotics company, let's say you want to work in autonomous driving, right? It is important to understand, you may focus on artificial intelligence, or you may focus on just the computer vision part, but it's important to understand how the computer vision interacts with the navigation, that you sense something, you recognize an object, and then you make a decision so the car doesn't go and hit the object in front of it. So this will give you that background to be able to understand what is robotics overall. But you are not going to be an expert in everything. Nobody is. I am not, right? But we need to understand enough to be able to talk with each other. When you work in a team, you will be sitting with other people in the room, and you need to understand where they're coming from. And these courses are going to give you that flavor. So that is important. The other thing is, do not get scared with the names, with these acronyms, ME, EE, CS, whatever. This is basically coming from a bureaucratic requirement. This is a program. A program does not have a department, but a course has to be owned by a department, right? So these are things that as a student, it shouldn't bother you. But since so many of you are asking the question, so a course belongs to a department. So ME owns that course, EE owns that course, or CS owns that course. These are departments. Robotics is a program that it's interdisciplinary. So we have to take courses from different departments and build it. But it doesn't mean that just because there's a name ME or EE that it's a very advanced course, that an ME course cannot be taken by an EE or CS student, or a CS course cannot be taken by an ME student. This is basically coming from the bureaucracy of keeping all this paperwork done properly. Okay, let me look at the other questions that came in. If I already took CS 229 and I didn't have a comprehensive exam, will I need to retake the course if I apply for the robotics? I do not think you need to retake the course, right, Kim? Do you want to?
No, Probably that wouldn't be the best option, and there's enough flexibility and course options built into the robotics program that there'll be plenty of other classes you can select from.
Yeah.
But
So you should, yeah. Yeah, go ahead, Kim, sorry.
Oh, one thing I was going to mention is that a lot of times I get asked if by students, if they need to take remedial courses or undergraduate courses, if that's going to extend their degree time. And I would say that in most cases, it shouldn't, because there's enough courses and course options within the program that we can work with you so that you can pick the right elective courses so that you don't have to extend your program time and still work that in.
Yeah.
Would you
So I'm pretty sure you will not have to retake the course. The graduate advisor always has the power to give you the option to waive a particular course. There's this question: apart from programming language skills of MATLAB, C++, and Python, which CAD software tools should a robotics student have? June, do you want to take that question on the CAD software?
Oh yeah, I just answered in the chat. So,
Okay.
so I believe during this kind of courses, you have some chance to pick up the skills. And if, for example, if you know how to use SolidWorks and other similar software, it'll be very helpful. But you can always learn it during class. And for example, in ME 2025, there will be some like lab sessions during which you will learn how to use this kind of software. So they will be helpful for students who have never used it before. Yeah.
Mm-hmm. Yeah, and actually, I would want to take that and try to answer the question that we talked about earlier, that whether an EE or CS student would have problems with a course like ME 225. So knowing a CAD software like this is not going to make you an expert in going and building a robot. You will not be able to completely build, but you will know enough about building a robot to be able to talk to somebody when you go into work, so that you have the skill set to be able to converse with each other. And that is what this kind of a program, of a course, will give you.
So I have also been asked before about the project option, basically how students can graduate with a project option, and if the project option has credits components to it and it's part of the graduation 40 units, because earlier you guys mentioned the total requirement is 40 units. And does that include the project option? And if so, this is
Yes.
additional or not?
Right. So, so basically, if you do, so the project is 8 units. You can do the project, or you can do 2 elective courses. So if you do a project, it could be done in one quarter as 8 units, or you could do 2 elective courses. The reason for the project, and so yes, so the short answer is the project is part of the 40 units. Now, the project is something that we would actually encourage everybody to do, everyone to take that path. But if somebody doesn't really want to, they can take the elective courses. We are actually working with some companies in robotics and AI to come up with projects that are specifically of interest to them. And then working on this project, the students will get an idea of what could be things that they would be working on when they go to work at that company. So this will be kind of like a baby project of an actual project that they will be working on in the company. So the project option is something that we would encourage all students to be working on. And we have a facility. Actually, we just set up, for example, a motion capture system where you can go in and work on your projects. You'll have robots to work with. So your background will not just be the theory, but you will actually have worked with hands-on robots. You'll have actually programmed, let's say, a computer vision system or a machine learning system, integrated it with a robot, and that will give you a huge edge when you go out to apply for those jobs, as compared to students coming from the more conventional ME, EE, or CS programs.
Thank you, Amit. Anybody else has any other questions? Okay, well, if you do not have any other questions, please feel free to contact our program via the email address here. It's robotics.ms@engr.ucr.edu. And Kim, just thank you for reminding everyone in the chat. Please email us and we'll be able to answer all the questions. And you just met with everyone who is involving with the program and who are leading the program. So it's always good to know us in advance and ask questions. And yes, thank you, Angela, for the reminder. And international students deadline is a little bit earlier, but July 15th, and domestic is not till September 1st. But again, the earlier you apply, the earlier you would get a chance to be reviewed for admission. So please take advantage and prepare early. We will be sharing the video link instead of the slide itself, so you will get the full presentation later on. I think we just got another question from Ankit Gupta. I'm a graduate of mechanical engineering, building up knowledge, which is almost matchable to syllabus of robotics, and know the basic knowledge of all courses due to online specialization course. Is there any chance to get a financial aid on the basis of GRA? I think GRE, that's what you mean, right? I think we don't provide additional financial aid. Kim, Emmett, please correct me if I'm wrong.
Not directly through the program, but I just linked to the funding resources for the campus, and they have a bunch of funding resources on campus, external funding. There's more than, you could spend hours and hours looking through all of the really helpful resources on that website.
Correct. And we'll be sharing the webinar recording to all the people who have registered for this session. So you will get an email and Angela will facilitate that. All right, so I guess it's getting late in California here. It's almost 9 p.m. and pretty early for some of you in Asia time zone. So thank you again for joining us for the University of California, Riverside Robotics Master Program seminar. And if you have any other questions, again, feel free to email us and looking forward to your application. Thank you so much. Have a great night.